In this video, we are going to be learning about histograms. So let's begin. So histograms are a kind of chart or graph that show data in intervals. So it's kind of like a dot plot or a bar graph, and you could even say it is a kind of bar graph, but here it is. Here's an example of a histogram. And what makes it a histogram is in a regular bar graph or dot plot, like you'd only have like one number represented. So if these are exam scores, you'd have like 1, 2, 3, 4, 5, 6, and then go all the way up to 35. What makes this a histogram is instead of having a single number, you can have a range of numbers, like interval of numbers. So 1 through 5, 6 through 10. These are the people who scored 11 through 15, 16 to 20. So bar graphs or dot plots just show, a single number. Histogram shows could show multiple numbers, like multiple numbers can be represented by a single bar. So histograms are similar to bar graphs, but the bars are not spaced apart. They are similar to dot plots because they represent the overall spread and shape of the data. So kind of like dot plots, you can look at the spread and shape, which is easier to look at than a series of like 50 or 100 numbers. You can see certain patterns that you can't see when you're just looking at just a bunch of numbers. So, for example, what kind of intervals are we talking about? Intervals sometimes could be decades, like a interval or a grouping of years, like the 90s, the 2000s, the 2010s, the 2020s. They could be scores, test scores, or grades. For example, people who score in the 80s have a B. People who have a score in the 90s have an A. People who score in the 70s have, a C. So that could be a kind of interval. You can also have age ranges. So, for example, anyone between 0 and 10 years old, 0 and 10, 11 through 18, 19 through 25, those would be like age ranges. All right, so let's go ahead and look at some examples. So data from the National ACT exam is shown in the histogram on the right. How many scores were included in the data set? So to answer this, we need to actually just count. So it looks like each little notch is, this notch, each long line is 5. And so each little notch, that looks like 1, 2, 3, 4, 5, each little notch is 1. So we should write down one person scored between 1 and 5. It looks like one person scored between 6 and 10. Let's see, it's 5, 10, 15. 15 probably looks like, I'm guessing 12? 12 people, not 13. Because it looks like it's a little bit less than half, that's 12. This looks like it is 34. It looks like this is this number's 25. This looks like this is 28 people scored that range. This looks like just above 15, so that's 16, and this looks like 3. So how many total people or total scores were included in the data? That's 1 plus 1. That's 2 plus 12. That's 14. 14 plus 34 is 48 plus 28. That's 76. 76 plus 16 is 92. 92 plus 3 is 95. I feel like, I am missing something here because according to, you know what? You know where I messed up? Right here. That's not 12. That is 17. 17. Sorry about that. So go back, fix that. That is 17. So 1 plus 1 plus 17 plus 34, 28. Let's make sure. 16 and 3. And that should be 100. So 100 scores. List the number of scores for each range. We have 1 for 1 through 5, 1 for 6 through 10, 17 for 11 through 15, 6 for 16 through 20, it's 34. For 21 through 25, it's 28 scores, 16 scores, and 3 scores. So, based off of this, which range of scores represents 17% of the data? 17%. Well, if there are 100 scores total, that means 17% would be 17 people or 17 scores. So that would be the 11 through 15 scores. Represent 17%. Number 2, what percent of the scores are included in 21 through 25 range? 21 through 25 is right here, and that is 28 people out of 100, which is 28%. What 2 ACT score ranges make up more than 60% of the sample? So 60% would be a lot, more than 60%. Which 2 age ranges would be like 34 and 28, which is, that's 50, that's 62, I think. So it would be the 16 to 20. If you add this and this up, you could say the 16 to 20 and the 21 through 25 age ranges. If you combine them, that makes up a total of 62%, I believe, which is more than 60. The histogram is symmetrical. What does this tell you about the median and the mean? In which interval would you predict the mean to be found? So symmetrical, it may not look exactly symmetrical, but it looks like it's smaller on the sides and it peaks at the top, in the middle, specifically. So we could assume that if it is symmetrical like this, then the median and mean are close together. Mean and median are close together. And also that the mean, where do you think the mean would be? It'd probably be in like the highest range because it is in the center. So I would say mean is in the 16 to 20 range. Mean is in the 16 to 20 range. All right, let's look at number 5. Label each of the statements below as true or false. Correct any false statements. So let's look at A. The number of scores between 1 and 5 and 26 and 30 is equal to the number of scores between 11 and 15. So they're saying 1 and 5, let's use a different color, scores between 1 and 5, there is an equal number of 21 through 5 and 26 through 30, as there are of 11 through 15. So 11 through 15 is this one right here. So if I added up this 1 and 16, would it equal 17? It would. So that is actually true. Let's take a look at B. The number of scores between 16 and 20 is double that of 11 through 15. 16, 20, let's erase these highlights. 16 through 20 is double of 11 through 15. So 16, 20, this is double of this. Well, doubling 11 through 15, 17 plus 17, or 17 times 2 was 34. So I would say that is true. And finally, there are an equal number of scores between 11 through 15 and 26 through 30. So 11 through 15, and then we look at 26 through 30, which is this one, and that is not true. There is there's more. There's more. One more. We can say there's one more in 26 through 30. We can also say, if you want to find something that's equal, 1 through 5 and 6 through 10 are equal, are the ones that are equal to each other. Let's go to the next page. So we've got these 2 dot plots here. Two histograms. The local library surveys its patrons based on their age. Use the histogram below to answer questions 6 through 9. So number of patrons is the number of people who go to the library and the person's age. So this is saying that people went into the library, it looks like 1, 2, 3, 4, 5, 6, 7, 8. That's 8 people were between the ages of 10 through 19. By the way, I'm writing this down because they want us to determine the total number of patrons surveyed. And we need to add this up completely if we want to do that. This is going to be 15 total. This is going to be 5 plus 1, I'm guessing. I'm guessing that's 6. I believe this is 2. This is 5, 6, 7. Yeah, slightly bigger than 6. And then the 60 through 69, that is, looks like it's 12. So, if I add that all up, 8, plus 12, that's 20, 35, 35, 41, 48, and 50. There's 50 total people. Number 7, how many library patrons are younger than 30? Younger than 30, well, 30 and over does not count because we want younger than 30, and younger than 30 means 29 and less. So that's 8 plus 15, and 8 plus 15 is 23. 23 people are younger than 30 in the survey. Based off of the information in the graph, which 2 age ranges are responsible for exactly 40% of the patrons? So 40% of the patrons, so let's think. Let's use a proportion for this. There are 50 people total, right? That's 100% of the people in the survey. I'm going to use a proportion. So we got to figure out what is 40%. What is 40%? So if a couple different ways to do this, you can do variable right there. You can do cross products if you want. You can kind of do the here to there method, which is like, okay, how do I get from 40 to this? Well, how do I get from 100 to 50? Just divide by 2, right? So 40 divided by 2 means this number right here is 20, right? So 20 people would be 40%. So which 2 age ranges are responsible for exactly 40%? So which 2 of these ranges, if I add them together, will get us 20? 7 plus 15 is too much. 12 and 8, 12 and 8. So if you add 10 through 19s and 60 through 69, you're going to get 20. So I would say the 10 through 19 and the 60 through 69. And number 9, based on the information in the graph, 30% of the library patrons are in which age range? So 30%. Again, we want to figure this out. A couple different ways we can do this. I'm going to use a proportion because I like proportions. So if 50 people is 100%, what percent is 30%? So how do I get from 100 to 50? You divide by 2. So 30 divided by 2 is going to get me 15. And that makes sense. If 40% is 20, then 30% is 15. Which age range has exactly 15 people? It is going to be this one, the 20 through 29 range. All right, let's look at the other histogram. The histogram is about a group of runners that chart their distance total for the week. Use a histogram to answer questions 10 through 12. So it looks like all these number of runners compared to the number of miles they run. How many of them ran less than a mile versus between 1 and 1.9 miles. And then the highest is like 4 to 4.9 miles. So how many runners run between 3 and 4.9 miles each week? You know what? Before I even answer these questions, I'm going to figure out how many runners were just in the survey. So over here it looks like 1, 2, 3, 4, 5. So that's 5. That's 5. That's 10. This one's easy. This is 5. I believe this is 8. and this right here is 12. So it looks like a total of 20, 30, 40. So it looks like I would say there are 40 people total. Total people. How many runners run between 3 and 4.9 miles each week? So 3 and 4.9, that's both of these. So that's this plus this. That's just 8 plus 12, which is 20 people. How many runners run less than 4.0 miles each week? So less than 4. So this is 4 to 4.9, so it's got to be less than 4. So it's going to be this plus this and this and this. Add all those up. 8 plus 10 plus 5 plus 5, that's 5, 10, 20, 28. That is 28 people total who run less than 4 miles. And question number 12, which of the following statements best represents the data above? 25% of the runners surveyed run between 4 and 4.9 miles each week. 25%. So 25% of 40, you got to think about that. So a quarter, if there are 40, how do you get 25%? Well, half, or 50%. 50% would be 20, and half of that, 25%, would be 10. So 25% of runners surveyed, so 10 runners? No, that's not true. 1/3 of runners surveyed run 2 to 2.9 miles. That's 10 people. So 1/3. 1/3 is not 10 because 25% is 10, and 1/3 is not 25%. That's 1/4. So that's false. And if you want to know what 1/3 is, you can just take 40 and times it by 1/3, which is 40 over 3. And if you, you're going to end up with a decimal, but you end up with about 13 point something, 13.3333, I believe. But that is not, that interval 2 to 2.9 is 10, not 13.3, not even 13. See, 1/5 of runners run between 3 and 3.9 miles each week. So 1/5 of runners. How do you find 1/5? You take 40 and times it by 1/5. 40 times 1/5 is 40 over 5, and 40 over 5 is 8. So, did 8 runners go between 3 and 3.9 miles? Yes, they did. That is true. And let's try the last one. The number of runners surveyed who run less than 1 mile is equal to the number of runners surveyed who run 3 to 3.9 miles each week. So they're saying number of runners who do less than a mile, which is this, is the same as those who run 3 to 3.9 miles, which is this. 5 is not equal to 8, so that is not true. So the only true statement is C. All right, so hopefully you understand histograms pretty well. Go ahead and try answer some questions about histograms, maybe make some of your own. Good luck.